a theorem that tells us how to quickly take derivatives if we have a power function. So instead of having to do the difference quotient each time and take the limit as h goes to 0, we now are going to start learning these rules so we can take derivatives much faster. So this theorem tells us if we're taking the derivative of a power function, then we just take whatever exponent is currently the exponent of the power function, move that down to become a coefficient, and then your new exponent is just your original exponent minus 1. So for example, say you want to take the derivative of x squared. Well, that's just going to be, we're going to have x, and then as a coefficient, we're going to have 2. That's just the exponent that was up here before. It comes down as a coefficient. And then our new exponent for the x is just the original exponent, which is 2, minus 1. So then that just equals 1, so we just get 2 times x as our answer. So that will be the derivative of x squared. So you can see the power rule is very... Okay, so let's work a few examples. Let's take the derivative of each of these functions with respect to x. So first of all, in part A, we want to take the derivative of y with respect to x. So that's the same thing as d dx of x to the fifth. So this is a power function, so we can use our theorem we just talked about. So then we get 5 as a coefficient, because this exponent comes down in front, times x to the 5 minus 1 power. So we get 5 times x to the 4th power as our derivative. So in part B, we need to take the derivative of x. So again, this is a power function as well. We could think of this as the derivative of x to the first power. So then we just use the power rule. That 1 comes down as a coefficient. So we just get 1 times x. And then it's going to be to the 1 minus 1 power. So we just have 1 times x to the 0. But of course we know x to the 0 is just equal to 1, so then we just get 1. So that's our derivative of x to the first power. Okay, in part C, we want to take the derivative of x to the negative 4 power. So using our rule, that negative 4 is going to come down front as a coefficient. So we have negative 4 on the outside as a coefficient. And then we have x to the negative 4 minus 1 power. So that equals negative 4 times x to the negative 5 power. And you can leave your answer like that, but we know, because of our negative exponent rules, that if you have a negative exponent, that means you take the reciprocal. So this is also the same thing as negative 4 over x to the 5th power, positive 5th power. So this is probably a little bit better way to write your answer, but you also could have written it like this. So let me just do a quick review. Hopefully everyone remembers the negative exponent rule I just used. So x to the negative 5 power is just the same thing as 1 over x to the positive 5 power. Remember, whenever you have a negative exponent, that just means you take whatever you have here and put it below the fraction line. And then you make the exponent positive. But remember, if you have like a negative 4 out front here, that does not have a negative 5 exponent. The negative 5 exponent's only going to the x. So like this stuff is separate. So if you have the negative 4 out front, it does not go in the bottom. It does not go in the denominator. It would just stay on top up here, which is what we had in that example. But sometimes this confuses people. So just remember, the negative 4 would not go to the denominator because it does not have a negative exponent. Only things with negative exponents would get moved to the denominator. Okay, let's do another example. This time we have exponents that are not integers. But like I said, that's perfectly fine. The theorem says the power rule works for any real number exponent. So in part A, we need to find the derivative of the 5th root of x. Well, remember what a nth root means. Remember this rule. The nth root of something is just, say x, is just x raised to the 1 over nth power. So like the square root of something is equal to that thing raised to the 1/2 power. So in the case of part A, we have the fifth root. So we can rewrite that as x to the 1/5 power. So I've just taken this and used the exponent rule to rewrite it as x to the 1/5 power. Okay, and now let's take the derivative using the power rule. So using the power rule, we know that the original exponent comes down as a coefficient. So we're going to have a coefficient of 1/5, and then we multiply that by x to the 1/5, the original exponent, minus 1. Now 1/5 minus 1 is like 1/5 minus 5/5, so that would give us negative 4/5. So our answer is 1/5 times x to the negative 4/5. But again, we can use that negative exponent rule if we want to move x below the fraction line and get a positive exponent. So we can write that as 1/5 times 1 over x to the 4/5. And then we can use the nth root rule again to transform this back into a root if we want to. We don't have to. So using the nth root rule for exponents, I can rewrite it like this. And then, of course, it probably would be good to write all this as one fraction. So then my answer would look like this. So that's probably the best way to write your answer, but any of these along the line would probably be fine. So this problem kind of looks like there's lots of steps because I kind of wrote everything out really individually in those steps there. Of course, you can write that out a little faster. But all these steps right here, and then also this step, all of that is just algebra. The only new thing we've learned about that is the new thing for calculus so far is this part, taking the derivative. So to be good at calculus or to do well in this course, it's maybe learning one new rule here and there, but then you have to know all the other algebra that you learned before. So you really have to know your algebra to be able to do these problems. So like I said, for this problem, there's just one step that was the calculus, and then everything else was algebra. And you'll see that over and over again when we're doing derivatives. Usually it's just one step that you do the derivative, and then everything else you just gotta do algebra to get it where you need it. Okay, in part B, we went to the derivative of x to the 0.7 power. So you know this 0.7 will come as your coefficient. So we'll get 0.7 times x to the 0.7 minus 1 power. So that will give us 0.7 times x to the negative 0.3 power. And then you could also write that as with a positive exponent if you would like. So you could write that as 0.7 over x to the positive 0.3 power. Or if you really wanted to, you could rewrite 0.7 as 7/10, and then you could write it as 7 over 10 times x to the 0.3 power. And also, if you really want to, you can rewrite the 0.3 as 3 over 10, and then use the nth root rule for exponents to write that with the root, but I don't think that would really be necessary. So we'll just leave this one right here as our final answer. But again, this guy or this guy would also be acceptable final answers.